assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
24.62, we have two spheres. One is charged initially with a charge q. The second one is twice as big. The radius is twice as big, depending on how you measure the bigness of the sphere. If it's the volume, then it's like 8 times as big. But anyway, it's initially uncharged. Then we connect them with a thin wire that is too thin to retain any charge. And we want to see, how do the voltages on each sphere compare. And then we want to figure out what fraction of that charge is on sphere 1 and is on sphere 2, and then find the ratio of their surface charge densities. So A, we have two conductors, or a single conductor rather, because the sphere is connected with a wire to the other sphere, and this is all one big conductor. And so their voltages are equal. Now for B and C, the voltage of sphere 1 is going to be Q1 divided by, let's just use Coulomb's constant, Q1 over R1 is going to be equal to V2, which is KQ2 over R2. And we further have that Q1 plus Q2 have to add up to Q, and that R2 is 2R1. So we can then solve for Q1 and Q2, and we find that Q1 over Q is equal to 1/3, and Q2 over Q is equal to 2/3. So this is B, this is C. Now D, the surface charge density is, of course, just the charge divided by the surface area. So 4 pi r 1 squared divided by 4 pi r2 squared. So then this equals Q1 over Q2 times R2 over R1 squared. And so then putting in the fact that we know what multiples of each other all of these things are, we find that the ratio of the charge densities is 2.